Alright, welcome back, guys. This is your video on take-home quiz, and we're just going to quickly go over this. Question number 1 says definition. Now, these were kind of obvious. Hopefully, you guys were able to finish your definitions before even watching this video. You know, you have them on the definition sheet. Definition of absolute value. Okay, and definition of absolute value says what? The absolute value of x is equal to x if x is greater than or equal to 0, negative x if x is less than 0. Make sure you guys are knowing your definitions for this upcoming week. All right, there's going to be several quizzes that require you to know your definitions. Number 2, first, definition of a function. Let's see, first definition of a function. What is a function? Is a machine. We're going to change that soon. A function is a machine. Now this upcoming week, we're going to change this word machine to a set of ordered pairs. We're going to change the definition to the precise definition this week. But for now, a function is a machine with an input called the domain and an output called the range. Okay? All right. So first two done. Number 3, 0 factorial. And if you guys remember, 0 factorial was by definition equal to 1. It makes no sense, but it works. So they decided to call this one. Number 4, the combination of n objects taken r at a time is n factorial over r factorial multiplied by quantity n minus r factorial. Again, all of this should be on your definition sheet. If it's not on your definition sheet, make sure you add this to the definition sheet up to number 5. Permutation of n objects taken r at a time is n factorial over quantity n minus r factorial. And which of these is a bigger value? Which of these is a bigger value? Remember, permutation is the big value. Notice in the combination formula, we're dividing by something extra. Okay? We're dividing by an r factorial. When we divide by r factorial, the value gets smaller. And number 6 says solve negative 4 times the absolute value of x over 3 minus 5. I need to get out of the way of the camera. Is less than negative 16. Okay, now reminder, question, is this and or is this or? Okay, hopefully you're saying we don't know yet why, because the absolute value is not isolated. Okay, so we have to get rid of the negative 4 first. Also, notice your right side. Your right side is negative, so this should be like an alarm going off. All right, so we need to isolate the absolute value. The right side needs to turn positive. Let's see if that happens. So notice negative 4 is being multiplied. So what do? Divide by negative 4, divide by negative 4. What happens here? We get the absolute value of x over 3 minus 5. Notice when we divide by negative, what happens to the inequality sign? It flips, and negative 16 divided by negative 4 is positive 4. Now, notice that the sign flips, so we have an or statement. Also, the negative 16 became positive. I will show you guys, I still haven't done this yet, what happens when the right side is negative with respect to inequality. Okay, and also what happens when the right side is 0. We still haven't talked about this yet, but we will. So this is an or statement. We write two equations. X over 3 minus 5 is greater than 4, or x over 3 minus 5 is less than negative 4. Now, add 5. X over 3 is greater than 9, or add 5 over here. X over 3 is less than, when the signs are opposite, we subtract 1. Now, if x is being divided by 3, we have to multiply by 3. So it's multiply by 3, multiply by 3. We end up with x is greater than 27, or multiply by 3, x is less than 3. Now, remember, the answer has to be in inequality notation. I wrote that on the directions in class. Equality notation. And this just means make this look fancy. Okay, so do we compress or statements? That's my first question. Do we compress or statements? No. We just put braces. Okay, put a brace and a brace. And our variable is, now just brace. The variable is x, and we put a line representing the word such that. Okay? All right, number 7. Number 7 says, name the property. Name the property, and it says if x equals y plus z, and y plus z is equal to a, then x equals a. Reminding you, if the first is the second, well, let me do it like this. Here. Something like that. If the first is the second, and the second is the third, then what can we say? We can say that the first is the third. All right, first is third. This is the transitive, transfer, okay? Transfer of equality, or transitive property of what? Equality. So we're going to state the whole name. Number 8, name the property. Says the quantity cosine squared x plus sine squared x times 1 is equal to cosine squared x plus sine squared x. Now, ones and zeros. Remember, ones and zeros give clue to either identity or inverse. Now, we ask what we started with. We started with this cosine squared x plus sine squared x. Did we end with cosine squared x, sine squared x? Yes. If we ended with what we started with, okay, this is identity. Okay, so this is the identity property of what? Of multiplication. Okay. All right, next. Number 9. Number 9 says, Number 9 says time varies inversely. Now, what does inversely mean? Okay, if you guys remember, inversely means what? Inversely means as one goes up, the other goes down. Okay, as one goes up, the other goes down. Time varies inversely as the number of people working if 12 workers can do a job in 3 hours, I believe, how long would it take 4 workers to do the same job? Okay, so again, inversely means one's going up, one's going down. Now also, when we write the equation, when looking at a word problem, you guys have to pick out the keywords. It says time varies inversely as the number of people working. Okay, so we can say time varies inversely with the number. We can say time varies inversely with the people. We can say time varies inversely with the number of workers. I think most of the time in class we do workers. So why don't we say time varies inversely as the number of people working. So time varies is T equals K. Inversely means put it where? Inversely means put it on the bottom. So time varies inversely with the number of people working. You can use W for workers. You can use N for number. Okay, really N for number is more proper, but workers is fine. Okay, so time it varies inversely with the number of people working. It's just a variable. As long as your variable represents what you're talking about. Now, it says that if 12 workers, okay, so now we write an equation, we get, remember, 3 points for the equation, we get 3 points for the list, guys. So workers, if 12 workers can do a job in 3 hours, so workers equal 12, can do a job in 3 hours, time equals 3. How long, now time is blank, how long would it take 4 workers to do the same job? So my question is, before we even solve this, okay, what's happening to the number of workers? Okay, the number of workers is going what? Down. Okay, so what's going to happen at the time? The time is going to go up. Now, if you remember, if you divide one side, you multiply the other. Or if you multiply one side, you divide the other. Remember, inverse means they're doing opposite things. Okay, so if the workers go down, by what do we have to divide by to go from 12 to 4? Okay, so to go from 12 to 4, you divide by 3. Okay, so if we divide on one side, we multiply on the other. So we multiply on the other side. 3 times 3 gives a total of what? 9. That's just one way. So the answer is 9, but let's work this out and show it. So I want you guys to show your steps. It says, let's start with what list? Let me erase this. Let's act like we don't know our answer is 9. Okay, we do. This is just a way to double check, but it's not always obvious. So let's go through the steps. So we start with the list that has no missing value. We put 12 in for W, and we put 3 in for T. So we get 3 in for T equals K over 12. Now, if K is being divided by 12, what do? We multiply by 12, multiply by 12. What do we have here? K equals what? 36. Now, once we have K, we're going to use K and W to find T. So we write T equals what? 36 over 4, which gives T equals 9. And so we see, as the number of workers goes down, the time goes up. All right? And last one on the first sheet says to graph h of x. H of x is equal to negative x squared plus 4. Okay, so first, let's identify, now we also have to write domain and range. Let's go and write that, domain and range. Okay, we have to graph this. Let's draw a graph. First, we have to identify what family are we in. What machine is around x? Okay, hopefully you say this is squared machine. This puts us in quadratic family. I'm just going to write this. Quadratic family. Quadratic family. And notice, 4 is being added on the outside. So our vertex is at 0, 4. Okay, remember, inside is before the squaring takes place. If it's outside, this is after the squaring takes place. Notice 4 is being added after x is being squared. So this 4 is being added on the outside, resulting in a vertical translation. We leave the 4 alone. Nothing is happening on the inside, so we're not going left to right. We're just going 4 units up. So the vertex is at 0, 4. Okay, let's mark the vertex, 0, 4. And what is the pattern of the quadratic family? Pattern of the quadratic family is right 1, up 1, right 1, up 3, right 1, up 5. Okay. Now, instead of going up, notice, our question, do we have a dilation? Do we have a dilation? Something being multiplied in front of x squared other than 1? No. Okay, so we do not have a dilation here. So our distances are still up 1, up 3, up 5, but we do have a reflection. So if you circle the negative and write reflection, okay, this just means instead of going up, we're going down. Okay, same distance. So we're going, instead of right 1, up 1, right 1, up 3, right 1, up 5, we're going to go right 1, down 1, then right 1, down 3, then right 1, I think we have enough room, right 1, down 5, okay, also left 1, down 1, okay, left 1, down 3, and left 1, down 5. And let's go ahead and graph the function. And we have to write domain and range. Now, if you remember, okay, domain of this family, what can go into the squared machine, guys, regardless of what this looks like? What can go into the squared machine? All real numbers. So our domain is from negative infinity to positive infinity. Remember, left to right, negative to positive. We go along the x-axis. Yes, yes, yes. We have function everywhere. Yes, yes, we have function everywhere. So domain is from negative infinity to positive infinity. Range, where do we start? We start at the bottom, okay? Negative infinity up to positive infinity. So down here, yes or no? Yes, 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 to a height of what? Height of 4. So our range is from negative infinity up to a height of 4, include 4. All right, so that's the first part of the quiz. And now let's move over to the second sheet. So I expected that most of you guys could knock out the first part. with no problem whatsoever. I think we're very, very strong on these topics. But the second sheet, permutation and combination, this is the difficult one. So let's go ahead and look at these problems and see what they say. Now, I'm just going to read them. I'm not going to actually write it on the board because it would take too much time. Let's try to keep the video short. You guys can follow along. You guys should have the sheet in front of you. It says, Jessica's going to college next year and plans on visiting the following 4 universities. Old Dominion. Okay, so I'm just going to write O for Old Dominion. University of Virginia. So I'm going to put V for the University of Virginia. The University of Richmond. Let's put R for the University of Richmond. And Virginia State. Okay, Virginia State. Let's put S for state. If Jessica and her parents plan to take 1 week to visit the colleges, in how many ways could they make the trip if they visit each college once? How many ways can they make the trip if they visit each college one time? Okay, so we're thinking in terms of, okay, is this permutation? You guys are trying to, is it permutation? Is this combination? Well, let's ask, is there assignment of position? Okay, so let's look at these 4. Okay, visiting Old Dominion first, then visiting Virginia. Okay, so if we visit Old Dominion first, then Virginia, then Richmond, then State, is that different than visiting Virginia, then Old Dominion, then Richmond, then State? Yes. Okay, is there assignment of position? Is there differences within the group? Yes. It's like having different prizes. Notice, in how many ways can they make the trip? They're asking, in how many ways can we assign position to the stops? Okay, stop 1, stop 2, stop 3, stop 4. Okay, if they visit each college once. Now, this is also not just permutation, but we don't use the formula here. We use common sense here. Okay, notice, we have 4 stops. And how many stops are they planning to make? They're planning to make all 4 stops. So this is objects, permutation of objects in a line. Okay, how many ways can you arrange things in a line? Notice. So if we just do this, 4 spaces on your paper, okay, how many options do they have for stop 1? In how many ways can they make the trip? How many options do they have for the first stop? If they're driving, well, they can stop at 4 different locations for their first stop. Now, it may not make sense, if they're traveling from south to north, it may not make sense for them to stop in the middle, then go back down, then go back up. We're not asking what makes sense here. We're asking how many ways could they possibly make this trip, okay? So how many options do they have for stop 1? Well, they have 4 different options for stop 1. After they stop at the first location, how many options do they then have for stop 2? They only have 3. And then after they make the first 2 stops, how many choices do they have for the next stop? Only 2 choices, and then only 1 choice. This is 4 times 3 times 2 times 1, which is 4 factorial. There are 24 different ways to make the trip, to schedule the stops, I guess. There are 24 ways to schedule the stops or make the trip. Now, another way to think of this is in terms of the formula, but I don't like you guys doing this in terms of the formula. Permutation, why? Because there's assignment of position. Stopping at Old Dominion first, then stopping at Virginia is different than flipping that around and stopping at Virginia first, then stopping at Old Dominion. So my question is, how many universities do we have to choose from? Well, we have 4 universities to choose from. And how many are they selecting to stop at? They're selecting to stop at all 4. Remember, when you have 4, choose 4. Okay, this is permutation of objects in a line. We do this, common sense is better, but let's look at the formula. We have what? 4 factorial over, on the bottom we subtract the 2, we get 0 factorial. Remember, 0 factorial is defined as 1, so we get 4 factorial over what? 1, we don't have to write this, okay, which is just 4 factorial or 24. All right, so the answer to number 1 is 24 different ways that they can schedule the trip. Number 2, it says your literature teacher gives you 7 questions to study. Okay. If 4 of the 7 questions will be on the next chapter test, how many different combinations of questions could be on the test? Now, I tell students, when you see the word combination, don't necessarily assume that this is combination because it puts the word combination in there. I have seen permutation problems where they insert the word combination. So let's not go by the word combination. Let's think for a minute. You're given 7 study questions. Let's call this question, let's call it question A, question B, question C, question D, E, F, and G. So I'm just representing questions by letters. Okay, a question about apples. Okay, a question about boxes. A question about cars. Okay, so I just represented the questions with letters. All right, so 7 different questions that you have to go home and study. Now, the teacher is going to select, you always have to think in terms of assignment of position. Okay, assignment of position. If there's assignment of position, then we're looking at permutation. If there is no assignment of position, we're looking at combination. So my question is, the teacher is going to select how many? If 4 of the 7 questions will be on the next chapter test, how many different combinations will be on the test? The teacher is going to select 4. So let's say this teacher selects A, B, C, and D. Remember also that combination means group. Okay, so she selects A, B, C, and D. Okay, so she puts question A first. She puts question B second. Think of if I gave you a quiz. Okay, if I gave you a quiz and I put the questions in this order. Would this be, what we're doing right now, would this be the same quiz if I put the questions in a different order? D, C, B, A. Would it still be the same quiz if I put the questions in a different order? Yes, it would still be the same quiz. Why? Because a group of 4 questions is the same as a group of 4 questions regardless. So it's asking, the question is asking, if the 4 of the 7 questions will be on the next test, how many different combinations of questions could be on the test? How many different groups? Okay, again, combination means what? Combination means group. So it's asking how many groups of 4 questions are there in 7? Okay, so to calculate this, we're going to use combination formula, combination of 7 total to choose from. How many groups of 4 are there in 7? And so we use the formula 7 factorial over what? Start with your 4. This is 4 factorial multiplied. Now subtract the 2. 7 minus 4 is 3 factorial. We end up with what? 7 times 6 times 5 times what? Stop at the larger factorial, 4 factorial over, and we have 4 factorial times, take the smaller factorial and write it out. 3 times 2 times 1. Now the 4 factorial cancels with the 4 factorial. Now I'm asking you, what is 3 times 2 times 1? Okay. 3 times 2 times 1 is 6, so we're going to cancel 6 with 6. Okay, did you catch that? We're canceling 6 with 6. We're left with 7 times 5, which is 35. There are 35 different groups of 4 questions in 7. Okay? Now, number 3. It says, the top 7 cash receipt crops grown in Virginia in 2008, on Virginia farms in 2008 were corn, wheat, soybeans, tobacco, hay, tomatoes, and cotton. So let's put letters to represent. Corn, wheat, soybeans, tobacco, hay, tomatoes. Let's put TM for tomatoes, so we don't get confused with tobacco. And cotton. So 1, 2, 3, 4, 5, 6, 7. Okay, again, we want to determine if there's assignment of position, which would mean permutation, or whether we're talking about no assignment or group. Okay, so we're looking at, suppose a Virginia farmer wants to grow 2 of the following: corn, wheat, soybeans, or tobacco. Corn, wheat, soybeans, tobacco. Okay, so we've got this. 2 of the following, and 1 of the remaining 3: hay, tomatoes, and hay, tomatoes. Let's put that little. Hay, tomatoes, and cotton. So he wants to grow 1 of these. So he wants to grow 2 of these. He wants to select 2 of these and 1 of these. Okay. So he wants to select 2 out of 4 and 1 out of 3. So my question is, looking at these 4, so he's breaking this 7. It's a little tricky. He's taking 7 things, breaking it into 2 different parts here. So he's selecting 2 out of 4. So let's write 4, selecting 2, and he's selecting 1 out of 3. So let's write 3, selecting how many? Selecting 1. So I'm just going to erase this. Okay, so he's selecting 2 of the crops out of 4, and he's selecting 1 of the crops out of 3. Now, my question is, if he selects 2 out of 4, for instance, if he selects corn and wheat, if he selects, wait, is that cotton or corn? Yeah, no, this is corn. Okay, he selects corn and wheat. Okay, he selects 2 crops. Does it matter whether he selects corn and wheat, and he plants corn and wheat, or would it be the same thing if he flips these around and plants wheat and corn? Okay, notice there's no assignment among the crops themselves. Planting corn and wheat is the same as planting wheat and corn. There's no assignment of position within the group. We're asking how many groups of 2 crops can he select out of 4. This is combination. So we're asking how many groups of 2 are there in 4. Okay. How many ways can you select a group of 2 crops out of 4? And how many ways can you select a group of 1 crop out of 3? Well, this is obvious. How many ways can you select 1 out of 3, guys? That only happens 3 ways. Okay, so this is combination, selecting a group of 1 out of 3, and a group of combination selecting a group of 2 out of 4. Let's set up the formulas. We're going to take the number of ways this can happen and the number of ways this can happen and multiply them together. Okay, and I'm going to show you why. So combination 4 choose 2, we end up with 4 factorial over 2 factorial multiplied by subtract the 2, 2 factorial. Notice this is 24 divided by 2 times 2. 2 times 2 is 4. 24 divided by 4 is 6. So we get a total of 6 ways that this can happen. I'm just going to put the 6 up here. And 3 factorial over 1 factorial multiplied by, subtract the 2, 2 factorial, we get a total of 6 divided by 2, which is 3. So a total of 3 ways this can happen. Makes sense, because how many ways can you select 1 out of 3? 3 ways. So we have 6 times 3. Okay. So my question is, could he has 6 options for crops. 6 options for crops here, 3 options for crops here. Multiply these together, we get a total of 18. The answer is 18. And let's look at this. So he has 6 ways he can select a group of 2 crops. So he's got this group. He's got this group. Let's call it group 1 over here. Okay, group 1 can be paired how many ways? Group 1 can be paired 3 different ways. Okay, he can either have hay, tomatoes, or cotton. Hay, tomatoes, and cotton. Group 2, okay, so his second group. Remember, there are 6 groups of 2 and 4. So his second group, group 2, can also have what? Hay, tomatoes, and cotton. Group 3 can also have hay, tomatoes, and cotton. Okay, so you start to see every group can have 3. Since there are 6 groups, and each group can have 3, this is 6 times 3, which gives a total of 18 different possibilities. Lastly, number 4. This one again goes back to permutation of objects in a line. It says that Chris decided to spend the summer reading from the following list of Virginia authors. David Baldassi here. So we have what? Baldassi, Wolfe, Spencer, Glasgow, McCrum, Poe, and I think that's all. That's 1, 2, 3, 4, 5, 6. Okay, Chris decided to spend the summer reading from among the following list of famous Virginia authors. Okay, these 6 famous Virginia authors. Now, if Chris chooses to read one publication from each author, starting with something written by Anne Spencer, how many ways can a goal be achieved? So my question is, he wants to ask, the question is asking how many orders in which he can read the book. So is there assignment of position within his choices? Yes. Okay, the question is Baldassi. Reading Baldassi first, then Wolfe second. Is this different than reading Wolfe first and Baldassi second? Okay, is there assignment of position? Yes, because what is the question asking with? How many ways, it says, if Chris chooses to read one publication starting with something from how many ways can the goal be achieved? So how many ways can he read these books? In how many orders can he read these books? Okay, so he's going to read all 7 of these books. Now if I said, well, I don't want to confuse. Okay, how many orders in which he can read these books? So we agree Baldassi first and Wolfe second is different than Wolfe first, Baldassi second. These ideas are not easy, guys, necessarily to spot. You know, difference between permutation and combination is just a difficult topic, guys. But let's see. Okay, so he's got, let's put 1, 2, 3, 4, 5, 6, 7 spaces on our paper. No, I'm sorry, there's 6. Put 6 spaces on your paper. Just like we did with question number 1. This is the same thing as permutation of objects in a line. He has how many books to choose from? He has 6 to choose from, and how many is he selecting? He's selecting all 6. Okay, if you do 6 choose 6, you get 6 factorial over subtract the 2, which is 0 factorial, 6 factorial over 1, which is 6 factorial, which equals 720. This is the wrong answer. This is the wrong answer. Why? Let's look carefully here. This is why I say objects, permutation of objects in a line. Okay, how many ways? This is the same question as number 1. How many ways can they visit the 4 universities? Okay, read carefully. It says starting. It says how many ways can he read the books if he starts with something written by Anne Spencer? So it tells you he's starting with something written by Anne Spencer. So does it tell you what he's reading first? How many options does he have for book 1? Okay, you want to say, well, he's got 6 options for book 1, then he has 5 options for book 2. No. How many options does he have for book 1? He only has 1 option for book 1 because it tells you in the problem that he's going to start with something written by Anne Spencer. So he only has 1 option for book 1. And then he has what? He has now 5 options for book 2, 4 options for book 3, 3 options, 2 options, and 1 option. So this comes out to 5 factorial, which is 120. All right, so great. This concludes the quiz, guys. I will see you Monday, and thank you for watching this video and completing your assignment. Good job, guys. Take care.